3, 2, 1. Okay, welcome one and all. My name is Saif Jasim, and today I'll be presenting my final year project. So my final year project is going to be based on the multiple disease detection using multiple machine learning algorithms. So starting off, I'll just let you know that my supervisor for this project has been Dr. Benita, and I really appreciate her assistance throughout the whole process. Moving on to the abstract. So for the abstract, we have predictive analytics. My topic of multiple disease detection under using machine learning algorithms comes under predictive analytics, because I'm going to be gaining a data set, then I'm going to be training the data set, testing the data set, and gaining much more information based on user input. So predictive analytics in healthcare offers promise for timely decision making based on extensive data analysis. Disease like diabetes, Parkinson's, and heart disease detection will be the primary focus for my disease detection system. And these three diseases, as we know, pose significant global threats due to the lack of timely checkups exacerbated by medical infrastructure shortages. Moving on to the introduction. So within the introduction, I'll be considering the aim, the objectives, and the main focus. So the main aim and objectives would be to develop a disease detection system with 6 machine learning algorithms. The 6 algorithms that I have considered are logistics regression, decision tree classifier, balanced random forest classifier, then support vector machine, K nearest neighbor, and finally I have also considered naive-based machine learning algorithm. These are the 6 algorithms I have considered. Based on the prediction by these 6 algorithms, I have chosen a voting system. A majority voting system will be executed on the predictions, and then and I have also designed a web app or website where the user can input data. Once the user inputs data, the 6 algorithms will be conducting their prediction. Based on this, a voting system will be executed. Once the voting system is executed, then the user or the patient will receive the final prediction. So moving on to the literature review. So of course in literature review, I have considered a total of 7 sources for the time being in this PowerPoint itself, where I have also considered at least over 15 to 20 resources in my final year report for this very topic. So for the time being, I have provided a preview using the 7 sources, and I have considered them under the literature source, major findings, methodologies, and gaps and limitations of each and every resource. So I've started with considering diabetes detection, Parkinson's detection, and then the heart disease detection individually. Then I've also researched on the different sources based on multiple disease detection. When I'm talking about multiple disease detection resources, these resources have also considered a few extra diseases. They consider plant diseases also, they consider breast cancer disease as well. But I have only made my paper focus on the 3 main diseases, which are Parkinson's, heart, and diabetes. So of course, starting off with diabetes detection models in Mexican patients by Antonio Garcia. So major findings would include the integration of feature selection techniques with classified algorithms. So of course they themselves have also included classified algorithms such as SVM, random forest, and more. This was for diabetes detection. Then I can also consider utilization of machine learning algorithms for diabetes diagnosis by another author. The random forest classifier yielded promising results for diabetes detection with high accuracy. So of course for different models, for different developers, depending on how you choose to execute your model, you will have a different level of accuracy for each one, and you will have a different level of preference. And one of the main things we need to consider during this process is the fact that your data set matters. Your data set, whether it's imbalanced, balanced, whether it's skewed, whether you have cleaned your data set appropriately, these facts have to be considered so that you can decide which algorithm is actually beneficial or which actually has an accurate prediction. Then next, I'll skip the diabetes prediction for the next one, and I'll go to machine learning based cardiovascular disease prediction, where application of machine learning algorithms like logistic regression, ANN for cardiovascular disease prediction, utilization of historical patient records for accurate predictions. Then the methodologies would include utilization of machine learning algorithms like logistics regression. Next one, I've also considered, these are the last three literature sources and for my literature review. So of course I have conducted artificial intelligence in diagnosis and detection of heart failure by Saif Jasim, where the major findings were integration of AI technologies in cardiovascular medicine, utilization of neural networks for heart failure diagnosis, and you will also notice certain gaps or limitations. So of course gaps and limitations include limited discussion on specific AI algorithms. Future research could be focused on validating the results on diverse data sets. And of course, we also know that one major gap that we can always address with all literature resources is the fact of debugging, and not only debugging but also troubleshooting throughout the entire process. Now I'll be going towards the research methodology. So during the research methodology, this comes under within 5 steps. So of course right here, unfortunately, the text is a bit small or it's a bit dark to see right now clearly. But the 5 steps I'll be considering are data collection, data pre-processing, models, model training, then train and testing, and model deployment. So within the data collection, of course, I'll start with an example. I have the diabetes detection data set. This was a 1981 PIMA diabetes data set which was collected on the PIMA Indian women who were all aged over 20. So this is an example of the data set that I considered, and it was the data was collected and loaded into a Google Colab file, which was my preference, of course. So Google Colab was used, and then I moved on to data pre-processing. Of course, data pre-processing included handling null values, handling question marks. It had many values were impractical. Pregnancies can be 0, but it does not make sense when glucose is 0 or insulin is 0 in my data set. So I had to handle this through the process of using mean values. So of course this can have its pros and cons, but that is a topic for another time for now. Then we can move on to the model selection. Okay, so the model selection, of course, I considered starting off with simple algorithms like logistics regression and even decision tree classifier. Then I also considered a few complex algorithms like balanced random forest classifier instead of random forest classifier only, because I am well aware that an algorithm like balanced random forest classifier is capable of handling an imbalanced data set. So this is an example with only keeping the diabetes detection in mind. Then next I went on the training and testing. So of course within the training and testing I split the data set into values that I feel comfortable with that are generally done. I selected an 80% for training and 20% for testing. So I conducted my training, and then I also conducted the testing or using the input values from the user. And then finally, I also have model deployment. Model deployment was executed easily through Streamlit options menu or Streamlit app. And for this, I used the environment of Spider, which was executed on Anaconda. This is just some background information which can help us further or with question answers moving forward. Then of course, hardware and software requirements. So mentioning the software or the hardware that I've used, basically I use Google Colab on an average laptop like this one over here, which can range from i5 to i7, and it is capable of handling the load that is required. Then additionally, Anaconda is surprisingly, I noticed, Anaconda is a heavy application that takes a little more longer time for loading. It takes a little more hard work by the RAM of your laptop. So that was also satisfied by my laptop, alhamdulillah. And so a few processor Intel Core i5 and AMD Ryzen 5 processor. Then software requirements, of course, I used Google Colab, so that was a lot more convenient for me. I was able to conduct or perform Python 3 code, and additionally I used Spider IDE, scikit-learn for machine learning algorithms, and a bunch more libraries which can be seen on my input on Google Colab file, which I can display later, of course, if required. Now, coming to the data flow diagram, so of course this you will notice is quite similar to, almost similar to my research methodology. You get a brief idea. So with the data flow diagram that I've presented here, the basic idea, I obtained my data set from Kaggle. Then I clean the data, pre-process the data, which is also known as EDA, Exploratory Data Accessing. And then, so I obtain the data set from Kaggle, data pre-processing, data training is conducted, and then I have also prepared my machine learning models. Save each of your machine learning models in your preferred way, of course, and then you just link it with the user interface. So my user interface will, of course, be displayed within the next 2 slides, hopefully. Here is a use case diagram. One thing I kept in mind, which was very important, was that right now I'm not only considering that if I'm a patient, if I'm part of the general population, so I will have to be able to use the website for disease prediction. What if I'm a medical professional? If I am a medical professional, I can already conduct the diagnosis and I can immediately use this platform that I have developed to help predict and give me a foundation for the disease and help guide my patient moving forward. So the use case diagram was using the disease prediction website or platform that I have developed. Then enter patient details, execute machine learning algorithms, and provide the disease status. Simple as that. Now considering the medical professionals scenario, they will diagnose the patients in fact. Then you have entered report details. Machine learning algorithms will be executed similar to the first option, and finally this will also provide the disease status. So both options are definitely available because you cannot always expect that your patient is well aware of what values to enter within the website app. It is always suggested, regardless of how further technology advances, it is always suggested that you take help or are diagnosed by a medical professional. So of course now I'll be presenting my implementation or output view, which you will notice, some of you will notice, is fairly improved from my previous demo. So of course I have the implementation of the output view where I have multiple disease prediction. Of course I use Spider and Anaconda, and I use Streamlit app for the main purpose, convenience and user friendliness. These two things were provided by the app, the Streamlit app, and I was able to present such a convenient view, such a user friendly view, where I have the 3 diseases on the site, opt for any disease. Then you have the diabetes prediction using machine learning. I chose the slider option because it is more convenient. You cannot always expect your patient to enter the correct value. They can be well unaware many times. So by giving them a set range, an acceptable range, and field validation format, this way they will be able to decide they will be able to easily decide the values just by simply sliding, and it will be predicted live. So here, just to give you an idea, I have also kept, along with my code, the debugging features. So debugging features were basically just to guide. Of course, I have kept this only over here. So you can see that as I increase the slider values, then the debugging user input, which of course do change as well, because the fact that I applied a scaler in my data pre-processing, I also need to take the same approach in my user input, where I have to descale my user input. Just to mention, I use the SMORT technique and standard scaler. Standard scaler were the 2 things I used in my backend for in the collab file. I need to keep these things in mind so that I can make a user-friendly interface for my patients. So this is one example. Now I want to also present the result. So of course the results are presented as is, with the final results being that the person is not diabetic. Now, moving to a professional view. A professional view would not include the debugging features. Of course, it would not include data that is unnecessary for my patient. It would only include the necessary fields. The patient will enter their value and they will get the result. As simple as that. So that's why I only presented the first idea for my diabetes detection to set the foundation. Next one, I have the clear idea through heart disease prediction using machine learning. All the values are right here with the button available heart disease test result. And this one with the results over here, I trained and tested. The person does not have heart disease. Similarly, I also have a complex one over here, which is Parkinson's disease prediction using machine learning, where the dataset had a bunch of features which were collected. So based on this, the values that I entered and tested, the patient is diagnosed to have Parkinson's disease. So as we slowly are moving forward, we come to the conclusion. So in conclusion, if I have hopefully made my point clear, In conclusion, the integration of advanced machine learning techniques in disease diagnosis offers unprecedented opportunities for improving the coordination with your coordination and exploring exactly how your conditions are moving forward. It offers unprecedented opportunities for improving patient care and outcomes. It embraces these technologies, requires collaboration, ethical considerations, and a commitment to advancing healthcare. Of course, I have a list of future enhancements right here, but I will just give it to you in brief. So the future enhancements would include the fact that I've noticed how my system is slightly or almost better suited for the patient as compared to a bunch of other systems. So the future enhancements I would consider are the fact that I can improve my data pre-processing. I noticed that my data sets, all three data sets, had a form of imbalance. All three data sets, of course, require data set cleaning. And this can, of course, be performed better. I can, of course, use a better scaler and even maybe use more technique which can benefit me whenever I have imbalanced data set. Furthermore, I can also consider a few more machine learning algorithms. And why only stop there? Not only machine learning algorithms, but I can also consider deep learning for moving forward. I could consider maybe CNN, I could consider a few like integration of more machine learning algorithms like neural networks, then gradient boosting and random forest. Of course, I won't mention, I only use balanced random forest classifier. Then of course I can advance feature engineering techniques can be used because during the pre-processing, I realized that many features were almost impractical at times, or the feature values were unnecessary. Then of course you have real-time monitoring and feedback and integration of explainable AI so that it can even guide patients who are unaware or untrained to use such devices or platforms. And then I just have my references right here, and I really appreciate the opportunity for presenting to you today. Of course, if you need any presentation from my side on the input or the output, I am available for that.
You have applied how many algorithms?
6 machine learning algorithms, ma'am. Shall I name them for you?
No, that's fine. Which is the best one?
So I noticed that balanced random forest classifier was the most suited. Why? Because instead of random forest classifier, balanced random forest classifier has the advantage that it can easily handle a imbalanced data set. And then on top of that, the second rating was for support vector machine because I only use a linear kernel for that.
Okay, and did you calculate the accuracy, how much it's coming?
The accuracy score was considered, the mean squared error was considered, I presented a confusion matrix also, of course. Then I also considered AUC score.
So what was the accuracy for the first one, for the top random forest?
Random forest, if I may double check in front of you, I have my codes right here. Okay, perfect. So from what I remember, the success rate for the accuracy score was almost 0.81 for balanced random forest classifier, but of course I cannot confirm, I didn't keep track. 3 diseases are there, that's why.
Thank you.
Yeah, thank you.
Basically, you consider the 6 machine learning models.
For now.
For each disease, you create separate model, or for all the diseases you combine all diseases?
No, I didn't take the risk. I created the 6 machine learning algorithms, scaled them for each individual disease rather than collectively because it would not be as satisfactory.
Okay. Can you go back to your presentation?
Yes, of course.
Use case studies. Okay, so here as we mentioned, the use case diagram, usually we use like standardized like symbols on the use case diagram to be like easily understood by technical and non-technical people. So why you didn't use the standardized like symbols, like act or like process? Why you used like here you should explain it for us to understand what's going on. But if you use the standardized format, like for example, act or processes, use cases, everything, it will be for the use case diagram.
Okay, for the use case diagram, if I use the normal format.
The normal format it will be more understandable than this. Okay?
Yes.
So that just try to make this correction in your report.
Of course.
And use standardized diagrams. It will be easily understood by technical and non-technical.
Okay.
Thank you, sir.
Thank you.